Welcome to another video in AZ-104 series for Azure administration. This video is about administer inter-site connectivity, and this is the part 2. In part 1, I discussed about the virtual network peering, service chaining, and how to set up and configure the virtual network peering with gateway transit and the forwarded traffic. If you have not watched that part 1 video, I'll put the link in the description. You can watch that part to learn about the virtual network peering for inter-site connectivity. This video will cover the routing in the virtual networks, how we use the user-defined routes to overrule the system-defined routing or default routing, and the service endpoints. I will compare the service endpoints and the private endpoints as well. This module belongs to the learning path, which is implementing and managing virtual networking, that covers 15 to 20% of AZ-104 exam. The learning objectives of this module are: review the system-defined routes, the default routes in a virtual network in Azure, identify user-defined routes, the UDR. I will be providing you a demonstration on user-defined routing, how we can route the traffics, or we can do the traffic shaping based on our requirement. Determining the service endpoint uses, in what use cases we should use the service endpoints and the private links or private endpoints. This video will help you understanding the network routing and the service endpoints. My name is Navneet Kumar. I'm a Microsoft certified trainer. Without any further ado, let's get started with network routing and service endpoints. When we talk about the routing within the virtual network in Azure, this is slightly different than the on-premises. In on-premises, if you bifurcate a network into multiple subnetworks, then you have to set up the routing to allow the services from two different subnets to talk to each other. But in cloud, this is not the case. In cloud, we have default routing between the subnets inside a virtual network. This routing is predefined by the provider, and this routing is known as system-defined routing. This system-defined routing is used to direct the network traffic between the subnets across the different subnets. We have some virtual machines or resources that are running. We can get them connected. But in case if I want to do the traffic shaping based on my requirement, I have the choice to override these system-defined routes using my user-defined routing. You will notice in this diagram over here that the virtual network that is deployed is having the system routes that allow the connectivity between the subnets within the virtual network, or it provides the internet outbound connectivity as well. There is an internet outbound or internet connectivity rule for routing as well, that you will see as 0.0.0 /0 with that slash notation and pointing towards the internet gateway provided by Microsoft. But if you want to do the customized routing, then you can create a resource called routing table, and then you can associate this routing table on the subnets and then define your static routes within it. These static routes will overrule the system-defined routes. Just a note here that the system routes cannot be modified. You cannot modify, or in fact you cannot delete or make any changes to these system routes. So the only choice you have is to overrule these routes either with BGP, if you have BGP enabled routers and you have hybrid connectivity, or on top of it we have static routes that we define the routing manually through a route table. Traffic between virtual machines in the same subnet is there. Between virtual machines in different subnets in the same virtual network, we can control data flow from VMs to the internet. Also, we can control whether it will be going through the internet gateway of Microsoft, which is through the default route, or I want to use my own network virtual appliances. So I will drop the packets to that network virtual appliance, and then that network virtual appliance can decide based on the rules configured that whether this traffic can be forwarded further or need to be dropped. Communication between VMs using the vnet to vnet VPN we can do. Site to site and express route communication through the VPN gateway, we can also establish this connectivity to route the packets to our on-premises for single tunneling or forced tunneling. Identify the user-defined routes. A route table contains a set of rules which are actually the static routes, and that specifies how packets should be routed in the virtual network. User-defined routes are custom routes that control the network traffic by defining the routes that specify the next hop of the traffic flow. This next hop can be none if you want to drop the packets to the target or destination CIDR block, or it can be the internet gateway, it can be the virtual network if you want to keep the traffic within the virtual network, or it can be virtual network gateway if you want to drop the packets to the on-premises and then decide through your on-prem firewall that what to do with that data. Or it can be the network virtual appliance where you can put the IP address of your network virtual appliance and route the traffic, that you will see shortly in a demonstration I'll be providing you about the user defined routes. The next hop can be the 5 different things we can use here. Like I mentioned recently, it can be none to drop, network gateway, vnet gateway to send the packets to the on premises and inspect them, virtual network if you want isolated virtual network, keep it within the vnet, internet gateway provided by Microsoft, or the virtual appliance. When you go with virtual appliance, you get an additional option or field, that is to provide the IP address of that virtual appliance. That can be either a virtual appliance, a virtual machine running some firewalls on it, or you can use the network or cloud services as well, like Azure firewall. Let us look into the route table, how to create a route table, how to create a route in it, how to associate it to a subnet and control the traffic flow. Welcome to another video. In this demonstration, I will perform the traffic shaping of this app server 1 virtual machine in Azure, which is part of a virtual network that you will see here, that the virtual machine is in this network with the test vnet and app subnet. This is the public IP on this server. The server has instance level public IP, you can say, and these are the inbound rules and outbound rules through the NSG to control the flow or the traffic. Well, I want to configure the user defined routing. Before that, I will show you the system defined routing on this interface of this server. This interface is this app server 1, and then some random number is added 296 on this interface of this server. I will click on that, and on the help tab on the left side, you will see a blade called help. You have the option to see the effective routes, where from you can check the routing of this network interface card. So click on help and select the effective routes. Here we go to the effective routes and see that there is a table of system defined routes, and these are all default routes. You can download these routes to have the report, but you cannot modify any of these routes which are predefined for this virtual network based on the address spaces I have added, or for internet outbound connectivity you will see there is a default route. So the source of these routes is default, state is all of them are active, and these are the address prefixes and the next hop type, that where the traffic will be sent. You will notice that the 0.0.0/0 is configured for internet. This destination prefix is configured to be routed to the internet, which means that any outbound traffic or any destination will go to that. But yes, if there is anything that is higher number than this /0, like I have 110.0.0/16 and 172.30.0.0/16 address spaces on this VNet, they have been routed through the virtual network only. So which means that for those IP addresses, the traffic will remain private within the VNet. It will not leave the network's boundary. These are some other default routes that are configured on this network interface card. I cannot modify any of these routes. As I mentioned earlier, I can see that there is no associated route table on the subnet where this machine is connected. That is what we are going to see now in a while, where we will be creating a route table and associating it on a subnet and overriding these default routes. Like I said earlier, that the default routes cannot be modified, but in case you want to do the traffic shaping of the network based on your requirement, then you can do it with the help of user defined routing. I will show you the connection to this virtual machine first, and will show you that the machines have internet outbound connectivity by default. That was also mentioned in the explanation through the slide deck earlier, that the virtual network you deploy in Azure has the internet outbound connectivity by default due to the system defined routing. The route you have already seen, that 0.0.0/0 is routed to the internet gateway of Microsoft. So that's Microsoft provided internet gateway. And if I show you what is my IP address, so there will be some IP address where this traffic is being redirected. That's the internet gateway provided by Microsoft. Well, we can check it either here or disable it, or we can use the Edge browser and then we can check it. So what is my IP address.com? You will notice that the machine is using this IP, that is 52.186.83.72 to connect to the internet. The machine has the internet connectivity right now, and I go back and create a resource, and that resource will be a route table. So I will look for the route table in the marketplace, and from the Microsoft as a publisher, I will choose the route table and create this resource. Creating the route table is quite straightforward. You have to provide the resource group, the container where you want to store it, the subscription, the region, the name, and then whether you want to propagate the gateway routes to this or not. So if you have BGP enabled routers and you want to propagate the routes to this route table, then you can keep it turned on. Tagging is optional, but you can provide it, and in fact in production it is used for billing or for classifying and categorizing the resources. And finally, I deploy this route table. I will click create and create this route table. Once the route table is created, your next job will be to add the static routes to this route table to define the traffic shaping based on your requirement. That is what we are going to do next once this route table is created, and then we will associate it on the target subnet where we want this route table to be effective. So this is the resource, the route table. Here under the settings blade, you will see the routes. By default, there is no route in the route table when you create it from scratch. And then you can provide the route a friendly name for what purpose you are creating this rule. For an instance, this is for internet outbound connectivity. So I'll choose that. Destination type is be it IP address or the service tag. And then the destination IP address, I'm creating a conflicting route with the system defined route to show you that this will override the system defined route. So this is 0.0.0/0. Next hop type, I will go with this drop down and will choose the virtual network gateway. And this is where from I can route the traffic to my on-premises and can do the single tunneling. I can route or send the traffic of my app servers through my firewall of my corporate network in on-premises. So we do it for forced tunneling or for single tunneling purpose when we have the hybrid network. But suppose if I want to keep the traffic within the virtual network, I can choose virtual network only. Or I have 3 more options. So there are total 5 options, and you will see this next hop address is grayed out for 4 options only for virtual network appliances. it is enabled to provide the IP address of the routing device or virtual network appliance. This is the internet gateway. It will be based on the default route also. That default route you also have seen was the next hop type internet in that default route. So there won't be any difference actually, because the default route is already in this configuration. So this does not make sense to me for this to put here. None means that drop the packets. So the packets for any IP address will be dropped, but of course for that /16 notation, two address cider blocks that you have seen, they will win over this, and the traffic will be routed within the private network. So your network will be completely a private virtual network inside the Azure. It will not have any internet outbound connectivity. But suppose you want to route this traffic through a firewall like Azure firewall or any network virtual appliances you have. So you can define the IP address of that network virtual appliance through which you want to route the traffic after being inspected. So that firewall's IP address or router's IP address you can put here. Well, this is how you can route the traffic of a subnet, entire subnet. So actually the route tables are applied on a subnet level, and you can associate a single route table on multiple subnets also if they share the same route. So that is also doable. Finally, we can add this route in this route table. In my case, suppose I want to drop the packets to the outside network, so I will go with none, or in case if I have my own firewall, any network virtual appliance, I can put its IP address here. I'm going to drop this traffic and going to add this route to this route table. Now I have a route in this, and I can add more routes. You see the button is still highlighted. You can add multiple routes. Now subnets, which subnet you want to associate it with, you can click on that associate button, and from this associate button you can choose your virtual network and the subnet on which you want to associate this. So this is app subnet, and click OK. There we go. This is the route and the subnet where it is associated. Now we can check our network interface card of that virtual machine, our app server 1. I will look for the NIC of my server, and we'll go to the effective routes, and you will notice that the app subnet route table is associated on this. Now the name of the route table I provided was this, and there will be a user defined route, and because there is a conflict, so that conflicting route, default route, will become inactive. Right now it is showing as active. It can take few minutes to apply this route, so you can wait for few minutes. As I don't see any user defined route, I can see all default routes still on this network interface card. I will refresh this window, and after refreshing the page, I will check it again, and this is invalid. Now you see that the default route has become invalid, and the reason why it has become invalid is because there is a user defined route that is same route, that is 0.0.0/0, but in this case the next hop I have selected this time is none, which means there is no next hop. So that means if I go to my app server 1 and I check any internet outbound connectivity, there will not be any. Only the private connectivity using those two address spaces that are associated on the network, 172.30 and 10.0 with that /16 notation, only the privately the traffic can be routed within the virtual network. It can't go beyond the virtual network's boundary. Even the outbound internet connectivity has been blocked. So this is how we can decide the traffic shaping of our virtual network in Azure by defining our own custom routes or user defined routes, which always win over the system defined routes if there is any conflict. You need to be very careful while defining this routing. You need to design and plan your network, your subnets as per your routing requirements, and then create and associate these route tables based on the requirements. Now if I look for the internet connectivity on this machine, so there should not be any internet because the routing is not providing any internet outbound connectivity. That's how we can configure the user defined routes and can do the traffic shaping of our virtual network in Azure. Now that we have learnt about the routing in Azure Virtual Networks, how it takes place, let's talk about the service endpoints. We have some managed services, or you can say cloud services or platform as a service services that we may need to consume or connect through our virtual network resources. In this case, the virtual network services can connect to these cloud services using the public endpoint, which will be over the internet. The traffic will be sent. But if my cloud services are hosted in Azure and my virtual network and the resources like virtual machines inside that are also within Azure, rather sending this traffic or routing it through the internet, I can optimize this traffic routing using Microsoft's backbone network. And that provides me the high speed, low latent connectivity and keeps my traffic somewhere protected from the exposure to the internet. This is how I can leverage the service endpoints. In case I want the communication completely private, then I can think of using private endpoints or private links. I'll be talking about that further in the next slide. Here you see that we have many cloud services like the Microsoft Azure Active Directory, today known as Entra ID, Cosmos DB, Cognitive Services, Container Registry, Event Hub, Key Vault, Service Bus, SQL, Storage, Web Services. There are different app services, cloud services that can be enabled with the public connectivity, or maybe you want to connect securely privately by optimized routes or through optimized routes. In that case, you can enable the service endpoint. It can take up to 15 minutes to enable it. The process is quite seamless. What we achieve with this, we improve the security of the resources. We get optimal routing for the services because the traffic is routed based on the through the Microsoft's backbone network and through an optimized route instead of the internet route. And it uses the Azure backbone for this routing, and it is simple to configure as well. In this following demonstration, I'll be showing you the service endpoint and then the comparison with the private endpoints or private link. What is a private link? In this case, if we have some platform as services and instead of connecting through the Microsoft's backbone and optimized network, I want to connect it through my virtual network's private traffic privately, just like I connect two private services within the virtual network, then I can create a private link and a private endpoint. Private endpoint is nothing but a network interface that is added and to your PaaS services, and this allows the connectivity of your virtual machines running inside the virtual network to connect to these PaaS services like SQL database or storage you want to connect in a complete private manner using the traffic of your virtual network. The private connectivity to services on Azure it offers, traffic remains on the Microsoft network with no public internet access. In earlier case in service endpoint, the traffic was sent through the Microsoft's backbone and optimized route, but here this connectivity is completely private in the cloud using your virtual network traffic. Integration with on-premises and peered networks also is possible. In the event of security incidents within your network, only the mapped resources would be accessible. Now, without any further ado, let's have a look into the demonstration of the service endpoint and the private endpoint, and there I will also compare the two things which are or which look similar but they are different in their functionality. So let us see this with a live practical demonstration between the service endpoint and the private endpoints, how to use them. Welcome to another video. In AZ-104, I have created a storage account. This storage account, if I show you, is this storage account with the networking configured as the public endpoint as of now. When it is public endpoint, then this storage account will be connected from any network. As you see the setting, public internet access, public network access, and enabled from all networks. In this case, there will be a problem with the performance and the reliability. If my clients are in the virtual network, then I can optimize this connection. So what I can do is I can go to this enable from the selected virtual networks, and then I can pick a particular virtual network. So I can add that virtual network here. So by going to this add existing virtual network, I will choose the virtual network, for an instance their VNet or any virtual network that I have, and a particular subnet from that virtual network. I have this test VNet with the app subnet also over here, but you see the endpoint status is disabled. For that, I will go to my virtual network and enable the service endpoint on the corresponding virtual network subnets. I'll go to the VNet. Oh, let me just save this configuration. And now I will jump to the virtual network, and in this test virtual network I will select the subnet where my server is. This is app subnet, and I will scroll down on the subnet to the service endpoint, and I will enable it for a particular cloud service. This time I'm using Microsoft storage account, so you can choose these services from here and then click on save. This setting will apply and will take few minutes to open this service endpoint to leverage the Microsoft's backbone network for the optimized performance. But you must have observed that from the storage account, the setting that is configured, it is still the public network. So if I take you back to the networking, here if I go to this networking, you will notice that this is public network access and enable from selected virtual networks and the IP addresses. But if I do not want public network access, then I will go with disabled. That I will discuss in private endpoints. First, let's see that how this traffic has been optimized from the virtual machines network to the storage account. For this, I have created a file share on this storage account. This file share is corp docs. I will open this corp docs file share and I will try to connect to this. I will choose a drive letter that I want to use and then will generate a script for Windows machine. You can use Linux or Mac. Now I will copy this script from here and I will switch to my server, which is a virtual machine. So this is a Windows virtual machine I have. If I go to the connect via Bastion, and do the RDP to this server, now I will run that PowerShell script in the IAC. I will paste that code here. In that script, the first line you will notice here is about testing a connection. Let me go to the storage account and take that script. File shares. docs, connect the drive letter, whatever the drive letter you need, show the script, copy it to the clipboard, take the script to the system. You will see the command is used to do the TCP port connectivity for port 445 to check the connectivity with that port. And on this machine, because it has default internet outbound connectivity, so it can connect to that port 445, and it can let me connect to this storage account over this network. Let me block this connectivity to the internet. So I go to the network interface and I will modify the NSG of this NIC. Let me just go to the NSG instead of taking you through this NIC. Otherwise, you will see on this NIC there is one NSG associated, which is this app server 1 NSG, the NIC level NSG. There is a default outbound rule which says that allow internet outbound. That is the reason that I am able to connect to that port and on that public IP, the remote address. And if I hit this script, then it will map this drive on this system. So the script will run and it is mapped. I will be accessing the storage efficiently in a optimized way. This is how the directory or this file share can be mounted. Now what I'm going to do is to test this public network connectivity, I'm going to add the rule over here and to the destination, which is my internet gateway. So it is going to be a service tag internet, and I will go with any port, so any to any, and I'm going to create a rule to deny. So I will disable internet outbound connectivity using this deny rule. So there is no internet outbound on the server, and this time you will notice that on the server, if I hit this command, it will fail to connect to the storage account service, and I will not be able to mount those drives that I mounted earlier. So I will disconnect my drives from here. The drives have been disconnected, and this will fail to connect this time, and so my script will also fail. So this is because it is false this time. So if I will try to mount this, so you see it is the public network it is trying to connect with, and because outbound internet connectivity is disabled, so I will not be able to connect to the service endpoint through this service endpoint to the storage account. Suppose this is the situation that I want to connect to the storage account privately, not through the Azure backbone network, but through my virtual network. Then I can use Azure private link. Private link is actually used to connect through the private endpoint. So what private endpoint is, let's have a look into this. So right now, the solution that I provided was through the service endpoint, and it was through the optimized route connecting to storage account. But in private endpoint, what happens is that within my virtual network, I will add a network interface which will privately connect to the storage account using the virtual network itself. So you can consider like the storage account service is running within your VNet. Though it is a cloud service, but it is running within your VNet, you can consider it like that. For an instance, I have web applications or Cosmos DB or Event Hub, service buses, such cloud services I have, and I want to connect them through the private connection through the virtual network traffic of my virtual network in cloud, then I can leverage this private endpoint. So to show you this scenario, I have blocked that internet connectivity and there is no public connectivity or public network this time to connect to the storage. So now I can use the private endpoints. All I need to do is I need to go to my storage account once again, and this time In the storage account, I will change this configuration to disable the public endpoints. When the storage account is no longer a public endpoint, then how will we able to connect to that? So I'm going to save this setting. It is completely a private endpoint. Now to establish a connectivity with this, I need to add a network interface. So this is going to be my private endpoint connection that I will create. Now then on the cloud service, that connection can be approved or rejected. I will give it a friendly name. This will be test Nick and okay, test 2 Nick, and East US is the region. Then the resource. So this is the target subservice that I want to use, file service. It will ask for the virtual network, in which virtual network and the subnet you want to introduce it. So I will choose my subnet over here, which is app subnet, where my app servers are running. I will dynamically allocate the IP to this NIC, or I can create a static IP for this NIC. I can define the application security groups for additional configuration, and then I will go with DNS. A private DNS zone will be required for the name resolution. Otherwise, you will have to connect to this storage account service, this file service, using the private IP allocated on the NIC that we have defined in this previous step. Now, if you already have the private DNS zone registered with that, you can leverage it. You will provide the tag for this. For an instance, it is project testing, and you will click on review and create. Finally, you create this private endpoint. By enabling this private endpoint, a NIC will be added to this storage account service, and this storage account service will be added to your virtual network. Unlike the service endpoint, which uses the Microsoft's backbone network to optimize the routing to connect to the storage services, the private endpoint will use the virtual network to connect to this storage account. So this time the storage account file service will be having a private IP address through which we will connect. Earlier in that case of service endpoint, you noticed that we tried to connect to that public IP, and this failed to connect to that public IP because the internet outbound is disabled through the NSG. There is no internet outbound connectivity on this server. So this server is completely isolated, having no internet inbound or outbound this time. And we will notice that we will still be able to connect to the storage service this time, because the IP will be the private IP this time for the storage account service. It will take some time to get it registered. I can check it on my virtual network that whether the private endpoint has been added or not. So I'll go to my VNet, which is test VNet. In this case, I will go to the private endpoints to check. Last time we used the service endpoints. So this was for Microsoft.storage service, whereas this time I'm using private endpoint. This test 2 has been added, and private endpoint network policy is disabled. I also can approve or reject this connection of this private endpoint on my storage account. So I have the option. So from the cloud service, I can decide that whether I want this private endpoint to be connected or not from a particular network. So if I take you to the networking and take you to that private endpoint, there will be the options to choose a particular connection and approve or reject that. So this is approved by default. As you see, the connection state is approved. That means if this deployment is completed and my server will try to connect to this, so this time if I will do this test connection to this endpoint, this endpoint will be using a private IP instead of using this public IP, which was 52.239 last time. So if I run that, it has obtained that 172.30.0.5 from that app subnet. The next available IP has been allocated to this endpoint, to this cloud service. Now I will run this script to map this drive, let's say T drive or whatever the drive you want to map on your system. So you will define that and then you will hit enter. Okay, the drive T was already there. I did it through the service endpoint connectivity. So let me use it with you, the next available drive letter. And you will see I'm connected to the storage account. This file share has been mounted on my server, and this has been mounted internally through the virtual network connections. So this is the difference between the service endpoint and the private endpoint. In a nutshell, the service endpoint is not ensuring the private connectivity to your storage account or the other cloud services that support the service endpoint. It is through the public network, but it is optimized routing through the Microsoft's backbone network.